Hi guys, I'm going to show you how to get the derivative of tan inverse x with respect to dx. So we'll equate tan inverse of x to y so that we can get y is equals to tan inverse x. Then to eliminate the power -1, we're going to multiply both sides by tan. To obtain tan y is equals to tan inverse x. These two will cancel out, leaving you with tan y equals to x. Now remember, this is just the same as this, it's just that we have multiplied both sides, and you know, multiplying both sides of an equation with the same number or whatever it is, it doesn't change the equation one bit. So we just get the derivative as our question had asked with respect to dx. So we know the derivative of tan y is sec squared y dy over dx is equals to 1. Some of you might wonder how I was able to remember that, but I would like to share something that I got from someone, that tan sec cot negative cosec. Using this, I can be able to get the derivative of tan, the derivative of cot, the derivative of sec, the derivative of cosec. So the derivative of tan will be the multiplication of these two. So the derivative of tan will be sec squared. The derivative of cot will be negative cosec squared. And what about the derivative of sec? It will be sec x tan x. What about the derivative of cosec? It will be negative cosec cot x. Okay, so this is something that you can use to remember. So from there, we know our equation now is sec squared y dy over dx equals 1. So we'll make dy over dx a subject of the formula. So we'll divide both sides by sec squared y, divide by sec squared y. So dy over dx equals to 1 all over sec squared y. And you know that sec y is the same as 1 all over cos y. Therefore, 1 all over sec squared y is the same as cos squared y. So our dy with respect to dx is just the same as cos y dot cos y. The dot just means multiplication. So I just simplified it into a form that we are used to. So once we have, just use the same techniques as we used in sin inverse x and cos inverse x. We let our angle, we had said let tan y, beg your pardon, yeah, here we had said let tan y equal to x. I'm sorry for hesitating, just looking for it and I think I just found it. So we had just let tan y equal to x, so our angle here will be y. Then using the acronym SOHCAHTOA, if this is new to you, TOA just means tan opposite adjacent. So tan y will be opposite, which is x adjacent y. So to get the hypotenuse, we'll have to use the Pythagoras theorem. So let me redraw the triangle, the right angle triangle. Sorry, it's not so straight. So this is y, this is x, this is 1. We're looking for the hypotenuse. We know that the hypotenuse is equal to the square root of base squared plus height squared. Our base is 1 and our height is x. So our hypotenuse will be equal to the square root of 1. 1 squared is just 1. 1 plus x squared. So our hypotenuse will be 1 plus x squared. So after filling in every variable required of the length, so we are looking for cos What is cos y? Since, okay, the reason as to why we didn't stop our answer at this is because our function itself was in terms of y. And since we equated our y, we made tan inverse x to be, our function was in terms of x. So since we had equated tan inverse x into y, we have to revert back to x. So that is why we have to revert this y into a form of x. So the cos of y will be using this acronym adjacent hypotenuse. So cos y will be adjacent, which is 1 hypotenuse, 1 all over the hypotenuse, which is the square root of 1 plus x squared. So remember we have two of them, cos y, have cos y and cos y here. So dy over dx, which was equal to cos y, and we've obtained cos y as 1 all over the square root of 1 plus x squared. It will be 1 all over the square root of 1 plus x squared multiplied by 1 all over the square root of 1 plus x squared. You know that if we multiply, if we have something like square root 2, this is just out of, I just want you to see what we're going to do here. If we have root 2, it's just the same as root 4. We just take this one, we multiply them, and then we put them under the same square root. It will be the same thing for here. So we'll have our numerator will be 1 all over the square root of 1 plus x squared, since there are two of them. Just as we've done here, square root of 2, 2 times 2, 4. Then you get the square root. What about for this case? We just put the square root sign, then we take the multiplication, the product of the two, and put it under the square root. So this and that will cancel out, so that we can get dy over dx equals 1 all over 1 plus x squared. And remember, we had let our y to be equal to tan inverse of x. So the derivative, our answer now, derivative of tan inverse x with respect to dx is the same as 1 all over 1 plus x squared. That's our answer. Thank you so much for watching.